Good evening to all. I am Subramaniam from SNS College of Technology, working as an assistant professor in Automobile Department. In this session, we are going to see about the squeeze casting, that is, casting of a piston using squeeze casting. Last class we have seen about the casting of piston using conventional castings. Now you see about the casting of piston using the squeeze casting itself. The squeeze casting is also known as a liquid metal forging. It is a process that combines the advantages of both casting and the forging to produce high quality, high strength components. This method is particularly suitable for manufacturing pistons due to its ability to produce components with excellent mechanical properties and minimal porosity. In this, we see about the metal selection used for the pistons are commonly made of aluminum alloys such as A356, 4032 or 2618. These alloys provide a good balance of the strength, ductility and thermal conductivity, and making them ideal for high performance and high temperature applications. And for this mold preparation, the mold is used in the squeeze casting is typically made of high strength steel to withstand the high pressure involved. The mold consists of two halves that form the cavity where the piston will be cast. Prior to castings, the mold is preheated to a specific temperature to ensure uniform metal flow and reduce thermal shock. A release agent is applied to the mold surface to facilitate the easy removal of the cast piston and enhance the surface finish. And next comes the melting and pouring. The aluminum alloy is melted in a furnace and brought to a required pouring temperature, typically between 700 to 750 degrees centigrade. The molten metal is then poured into a preheated mold cavity. Unlike the conventional casting methods, squeeze casting involves applying pressure to the molten material during the solidification also. Next, once the molten metal is poured into a mold, a hydraulic press or a similar mechanism is used to apply high pressure ranging from 30 to 150 megapascals to the molten metal. This pressure is maintained until the metal completely solidifies. Applying the pressure during the solidification ensures that the molten metal fills the intricate details of the mold, reduces the shrinkage and minimizes the porosity. And next, the high pressure applied during the solidification helps in achieving a fine grained microstructure and uniform properties throughout the piston. The mold is designed to promote the directional solidification, which ensures that the molten metal solidifies from the mold walls inward, minimizing the risk of the internal defects. And next comes the mold opening and ejection cylinder. After the metal has fully solidified, the mold is opened and the piston is ejected. The mold design includes ejector pins that assist in removing the piston without causing any damage to the cast. The ejected piston is then subject to further coating if it is necessary. Heat treatment. To enhance the mechanical properties of the squeeze cast piston, heat treatment process such as a solution heat treatment and aging are preferred. Solution heat treatment involves heating the piston to a high temperature to dissolve alloying elements followed by rapid quenching. Aging is then performed at a lower temperature to precipitate the dissolved elements, increasing strength and hardness of the piston. Machining process. The cast iron piston undergoes the various machining operations to achieve the required dimensions, surface finish, and features. This includes turning, milling, drilling, and grinding. Critical areas such as piston skirt, ring grooves, and pin bores are machined to the higher tolerances to ensure the proper fit and the function of the in the engine. And with this, we come to the end of this session. And the rest is in the next session. Thank you.